This question is from NEST 2007. Consider the polynomial function f of x equal to x cubed minus 9x squared plus 23x minus 15. X belongs to negative infinity to infinity. Option A, f of x assumes every real value at least once. Option B, mod of f of x is differentiable everywhere. Option C, f of x has a local minimum in the interval 3 to 5, closed interval 3 to 5. Option D, for x less than 0, the curve y equal to f of x lies entirely in the third quadrant of the xy plane. Okay, now this is actually a multiple select question, so there may be more than one option correct. Okay, alright, so we will start by writing down the given function, which is x cubed minus 9x squared plus 23x minus 15. Okay, now first of all note that coefficient of x cubed is positive, right? Coefficient of x cubed is positive, and therefore I can say that limit of f of x as x tends to infinity is infinity. Correct? So as x gets larger and larger, x cube is going to dominate all the lower power terms, no matter how large their coefficients are. So this is going to be infinity, and if x tends to negative infinity, then also we will not get the same result, but we will get numbers which are very large in magnitude but negative in sign. Okay, so hope you understood that. Limit of f of x as x tends to infinity is infinity, and limit of f of x as x tends to negative infinity is negative. Okay, now we know that f of x is a polynomial, right? F of x is what? Polynomial. And for polynomials, we know the characteristic that they are continuous and differentiable everywhere. So we can say therefore by intermediate value theorem, okay, by intermediate value theorem, range of f of x is negative infinity to positive infinity. Raise your hands if you have understood this particular argument. Okay, so option A is right. Okay, option A is right. Now to talk about option B, C and D, okay, talk about options B, C and D, let us take a look at the functions coefficients. Okay, let us take a look at the functions coefficients. Okay, now what is the sum of coefficients? Okay, have you looked at it? Sum of coefficients, let us see. X cube's coefficient is 1, x squared's coefficient is negative 9, x's coefficient is 23, and the constant term is negative 15. Okay, 23 plus 1 is 24, 9 plus 15 is also 24, 24 minus 24 is 0. Now what does this imply? This implies that f of 1 is 0, and therefore x minus 1 is a factor, right? X minus 1 is a factor. Now to find the other two factors, okay, we don't know whether they are real or they are complex conjugates of each other, the roots. Okay, one of the roots is definitely 1, so we can divide this polynomial. Okay, we can divide this polynomial by x minus 1. Let us see how, well, rather what we get there. Okay, see, we are bound to get 0 remainder, right? We are bound to get 0 remainder, but we would like to see the quotient. Okay, first we will have x squared, so it will be x cube minus x squared. With that negative sign, this will go, and this will become negative 8x squared plus 23x minus 15 will get carried forward. Okay, then what are we going to get? Minus 8 should be there, minus 8x, right? So it will be negative 8x squared plus 8x, correct? Again subtract, x squared goes 23 minus 8 will be 15x minus 15. So all we have to do is we have to just add 15 here, and that will make it 0. Okay. Now after successfully factorizing the given polynomial, let us check whether we can factorize the coefficient of the quotient, sorry, not the coefficient, the quotient, which is x squared minus 8x plus 15, correct? And it's not very difficult to see that negative 8 can be written into, well, split into negative 5 and negative 3, and so is this. And that's exactly what we need when we look for factors, correct? So we can write f of x as x minus 1 into x minus 3 into x minus 5. Okay, is it clear? Yes. Therefore f of 1 is 0, already known, f of 3 is 0, and f of 5 is also 0. Did you understand this? Yes. Okay, so our polynomial has got 3 real roots. Okay, now look, well, had we known that earlier, we would have directly checked for that, right? We would have checked for f of 3 and f of 5, but of course in the exam we will not be knowing that, right, unless we do it manually. Okay, so we have done that. F of 1 is 0, f of 3 is 0, and f of 5 is equal to 0. Okay, now let us come to this option D. Okay, option D says for every negative x, the curve lies in the third quadrant. Is it true? Let us verify. Okay, look now. Suppose this is our x-axis, okay, and let's say this is y-axis. Okay, 0 is here, 1 is here, 3 is here, and 5 is here. Oh, well, forget about the scale. Now look, when x is greater than 5, okay, when x is greater than 5, then what will be the function's value? Will be positive. We know that. When x is in between 3 and 5, okay, x is in between 3 and 5, what will happen? These two terms will be positive, but x minus 5 will be negative, so here the curve will be negative. Okay, and when it comes to numbers between 1 and 3, then these two factors will give us negative, and x minus 1 will be positive, so negative into positive, so again that would be positive. So to the left of 1 we are getting all negative values, right? To the left of 1 we are getting all negative values. If you understand this, because we know the factors, then you know that the shape of the curve, roughly how it looks, right? It's going to be something like this, and here it will go like this. Okay, and where will it intersect the y-axis? F of 0 will be negative 15, so wherever that curve is going to meet the y-axis, that point will be negative 15. So is option D correct? For x less than 0, the curve lies entirely in the third quadrant. Yes, it is, because after it crosses negative 15, the whole of the curve is going to be in the third quadrant. Okay, so option D is also right. Okay, option D is also right. Okay, option D is also right. Now, based on this particular picture that we have sketched, okay, let us decide which one of the options B and C is true, or both are true. Okay, or both are true. And just to support our arguments, okay, just to support rather the curve that we have drawn, the shape of the curve that we have drawn, what I think we should do is, okay, we should go for f dash of x. Okay, we should go for f dash of x. I'll tell you why, but first let us find the derivative of f. Okay, first of all let us find the derivative of f. Okay, what would it be? Dash of x would be 3x squared minus 18x plus 23. ठीक है. Now what is f dash of 1? It would be 3 minus 18 plus 23. Now we don't care whether what value it is, but we know for sure that it is positive. Okay, so the function is increasing at x equal to 1, we know that. Okay, now let us calculate f dash of 3. Let us calculate f dash of 3. What is f dash of 3? 3 into 9, so that is 27 minus 54 plus 23. Okay, 27 minus 54 plus 23. Now that is definitely less than 0, so the function's graph is going down and decreasing. Okay, and what is happening at 5? What is happening at 5? It would be 3 into 20, so that is 75 minus 90 plus 23. Okay, 75 plus 15 is 90, so this will definitely be positive, which means the function's graph is again increasing there. Okay, which now confirms that between 3 and 5 it has a local minimum, so C is right. Okay, between 3 and 5, well, because the sign of the function changes between 3, at 3 and at 5, so between 3 and 5 we must have a local minimum. Is it clear? Where is that located, we don't care, rather that's not of any concern to us. So option C is also right. Now what needs to be decided is whether option B is right or wrong. Okay, here they are saying mod of f of x is differentiable. Now look here, the graph of mod x will actually be the mirror image of the graph of f of x when f of x is negative, correct? So if I were to sketch the graph of mod x, okay, I will have a sharp corner here. Okay, I will have a sharp corner here. Okay, so because of these corners, okay, at x equal to 1, x equal to 3 and 5, mod f of x has corners like mod. Okay, now because of that it won't be differentiable. Okay, so it's not differentiable here, so B is not right. Have you understood our argument, what we have said there? At how many points is our function not differentiable? At 3 points. At x equal to 1 it is not differentiable, at x equal to 3 also it is not differentiable, and at x equal to 5 also it is not differentiable. Is it clear? Yes? Got it? Now let us verify this graphically. Okay, let us verify this graphically. What was it? X cubed minus 9x squared plus 23x minus 15. 1, okay, that's true. Okay, 135, that's perfect. And now let us go for mod of f of x. Oh, sorry, mod of this function. And as you can see, except that McDonald's thing, okay, like the blue only has different shape than the red one in whenever the blue is, the red is below the x-axis. Okay. Okay, now let's see if we can find the derivative of this function mod 1. Okay, the derivative here. Okay, now see, it is showing exactly vertical, so from this it's not going anywhere. Okay, it's not going anywhere. Here from the left, if you see, the derivative is negative 4, but from the right you see the derivative is positive 4. Okay, and see, this is a vertical line that the software has drawn. Okay, but that is not right. Okay, there is a discontinuity that our function is going to, it's not capturing it. Okay, well, maybe right here it has captured it. Okay, the function is discontinuous there, and therefore it is not differentiable, the original function. Got it?